Yo, I'm back. Hmm, Interesting. So, yeah, path with minimum effort is Dijkstra. Not anything, okay, cool. Okay, let's get these 10 questions done. Number of connected components in an undirected graph. This feels. Why am I going on to LinkedIn, brother? What the? Number of connected components in an undirected graph. Oh, on leetcode it is there, which is interesting. There is an undirected graph with n nodes. There is also an edges array where edges of a, b means that there is an edge between node A and B. Return the total number of connected components in that graph. So we can simply create an adjacency list first. We know that there are n nodes labeled from 0 to n minus 1, so it will be just vector of vector int. It will be a graph of size n, and the neighbors will be empty initially. Then we go through the edges. E in edges, graph of E0 dot push back E1, graph E1 dot push back E0. Then we create a visited array of size n initially. Everything is false. Then from every node we try to do a DFS and count the number of components. If not visited I, then do a DFS, pass in the graph I and visited, increase the component size, at the end return components. And then this DFS function is simply a standard DFS where we pass in this graph, the current thing, and the visited array. Okay. Now we simply say visited of current is equals true. Then we go to each neighbor of that graph of that current node. If not visited neighbor, then we say DFS graph neighbor visited. That's it, right? Is there any base case here? If it is visited already, then yeah, we can prevent that. But this will prevent that also, so no worries. Let's see if this works. Okay, accepted the standard test cases. Accepted, done. Cool. This question is done. Graph valid tree. Let's see this. Oh. Given n nodes labeled from 0 to n minus 1 and a list of undirected edges. And in the previous question, I failed to mention the time complexity. So time complexity of DFS and BFS is order of V plus E, since we just traverse each vertex and edge once. That is why it is V plus E. Even for topological sort, it is V plus E. For Dijkstra, it is E log V. Bellman-Ford is EV. Floyd-Warshall is V cubed. Bellman-Ford. Okay. Let's get on with this graph valid tree. Given n nodes labeled from 0 to n minus 1 and a list of undirected edges, each edge is a pair of nodes. Write a function to check whether these edges make up a valid tree. Now, what is a tree? Okay. A tree is simply a graph without any cycles, right? So I just have to detect cycles in this given number of edges, right? If I'm given this input, then I have to find if there is any cycle in this. And by cycle, I mean, cycle detection. How do I detect a cycle? So let's say we have a 0. 0 is connected to 1, 0 is connected to 2, 0 is connected to 3, 1 is connected to 4. If I do a DFS on any of these nodes, from 1 I can go to 0, I can go to 2, and I can go to 3, I can go to 4. Okay. So the point here is I can do DFS from any node, and if I can reach every other node, like if I go to 1 here, I can do BFS is a better approach, right? From 0, I can do a BFS. So in the next layer, it'll be 1, 2, and 3. And for the next layer, it'll be 4. But if this is connected, let's say, yeah, from 1 I created a layer, but from 2 also I created. So but this is already visited, right? Interesting. A tree is a connected graph without cycles. Even I can do DFS here. If I do DFS on 0, I go to 1. I also keep track of the previous node, like parent node from which this came from. Now, yeah, from 1 I can go to 4. Yeah, yep. Okay, makes sense. So interesting, very interesting question. So first of all, I can create a graph of size n for every edges. Graph of E0 dot push back E1. Graph of E1 dot push back E0. Right. Then we need a visited array size n false. Now, one question is, if there is a disconnected thing, that is not a tree, right? Yep. So I can simply say visited of 0 is true. DFS on graph starting from 0 with visited. Then I can simply check from 0 to n. If not visited of I, return false, otherwise return true. int current vector bool visited. I also need to keep track of previous, right? Yeah. Now, since these guys start from 0, I can say previous is -1. An invalid thing, just basically. Okay, now, visited of current is equals true. Then for every neighbor in this current, if visited neighbor and this neighbor is not equals previous, then return false. Otherwise, just do a DFS here. Okay, I'm back. So, can I return a boolean directly from this DFS? Yes, that's what I was thinking about. Return false. DFS graph neighbor current visited, right? Now I have a thing here. Okay, so we visit the current node, right? Then we go to each neighbor. We check if that neighbor is visited and that neighbor is not equals previous, then we return false. Else, if that neighbor is not visited, then we do this thing, right? Yeah. Let's see if this works. Okay, accepted. Let's submit. Yeah, it works. And I did solve this on April 21. Let's see, what did I do here? Check cycles. Yeah, parent and current. Yeah, pretty much same. So I created a graph and then in result, if return result, yeah. If visited current return false, then for every neighbor in current, if neighbor is equals parent, then continue, otherwise if not this, return false. Yeah, pretty much the same thing. Interesting. Okay, next one, redundant connection. Okay, this is not behind subscription, which is good. Okay, in this problem, a tree is an undirected graph and that is connected and has no cycles. You are given a graph that started as a tree with n nodes labeled from 1 to n, with one additional edge added. The added edge has two different vertices chosen from 1 to n and was not an edge that already existed. The graph is represented as an array edges of length n, where edges I, ai, bi indicates that there is an edge between nodes ai and bi in the graph. Return an edge that can be removed so that the resulting graph is a tree of n nodes. If there are multiple answers, return the answer that occurs last in the input. Interesting. So basically the point is, I have been given a number of edges. Then if there is an edge between two nodes, I can add them to the same component using union find basically. So if 1 and 2, if there is an edge between 1 and 2, I can say that 1 and 2 belong to the same group. Then if there is an edge between 2 and 3, then 1, 2 and 3 belong to the same group, right? And I have to check on every edge, like if they already exist in the same group, then that is a redundant edge. Now, point to note here is return an edge that can be removed so that resulting graph is a tree of n nodes. If there are multiple answers, return the answer that occurs last in the input. So I have to continue doing that union find until it reaches the end. So once again, I have to write a union find here that I did yesterday. A union find class. Pretty much basic. So we have two things here. First is the number of nodes. Second is the parent component. Third is the size. That's it. And public, there will be two functions. First will be find, and second will be unify. Now in find, returns the parent of the node. If parent of node is equals node, return node. Int parent equals find parent of node. This is root. Root is a better term to avoid confusion. Parent of node equals root, return root. Path compression. Now we can simply say int p1 equals find n1, p2 equals find n2. If p1 equals p2, return false, which means they already belong to the same component. Right, if they don't belong to the same component, then I have to check if size of p1 is greater than size of p2, then size of p1 plus equals size of p2 and parent of p2 equals p1, else size of p2 plus equals size of p1, parent of p1 equals p2. Return true at the end. Do I need anything else? Nothing. Now simply I have to create a new union find here. I need to write a constructor first. So in the public section, I'll just write a constructor union find. It takes in the number of nodes. And do I need anything else? No. So this n equals n, for int I equals 0, I is less than n, I plus plus, parent dot push back I, size dot resize n1. Now, one thing to note here is, since these nodes start from 1 to n, okay, a key point is that the n is not given. The graph is represented as an array edges of length n, so n is simply edges dot size n plus 1. Then I have to go through each edge, e in edges, vector int result equals, initially it is empty, right? Then I can simply check if unify e0 e1, then result equals e, return result. Let's see if this works. UF unify. Yep. Perfect. Maybe I have solved this. Yep, I did solve on April. Interesting. Redundant connection done. Reconstruct itinerary. Let's go this link, reconstruct itinerary. Okay, this is a hard question. You are given a list of airline tickets where tickets of I is from I to I represent the departure and arrival airports of one flight. Reconstruct the itinerary in order and return it. All of the tickets belong to a man who departs from JFK, thus the itinerary must begin with JFK. If there are multiple valid itineraries, you should return the itinerary that has the smallest lexical order when read as a single string. For example, the itinerary JFK LGA has a smaller lexical order than JFK LGB. You may assume all tickets form at least one valid itinerary. What is an itinerary? Okay. Oh, so all of the tickets form some sort of itinerary, right? Yeah. Okay. Tickets. Vector int graph. Now, okay, n is not given here. Interesting. So if there are 1, 2, 3, 4 tickets. 1, 2, 3, 4, 5. Okay, Atlanta to JFK, from JFK to SFO, from SFO then to Atlanta, then Atlanta to SFO back again. Oh, okay. So, it's kind of just a DFS, right? I have to start from JFK. Interesting. But I don't know n, right? But if there are like n tickets given, then there will be n plus 1 at most. Right. Yeah, if there are 5 tickets given, and at most there will be 6 airports, right? If there is at least one valid itinerary, right? So we can say int n equals tickets dot size plus 1. Ashrit Sitam Raju. Hey, what's up, brother? N vector of int. This is not int, by the way. This is a string. String. Right. Then for each ticket, T in tickets, departure is T0, arrival is T1. Then I can simply say, can I do an unordered map here? Yeah, it'll be, yeah, yep. Yeah, it's better to do an unordered map of string to a vector of string. Then we don't need this. Then I can simply say graph of departure dot push back arrival. Sort. If I do a set, it'll be sorted automatically, right? Yep. Then we don't need to sort here. Now, then I have to do a DFS. And I can keep a set, unordered set. Let's see the constraints, man. 300 makes sense. String visited dot insert starts from JFK. Travel starts from JFK. Now I have to do DFS on this graph starting from JFK current. Valid itinerary. Okay. Okay. So the problem, the issue that I did here is I went into the solution way too early. I didn't think much. So we need a couple of things here. Now these are tickets, right? So if I travel from JFK to Atlanta, I have to mark it as visited, that I have used this ticket already, right? I don't want to mark that Atlanta is visited because I can visit Atlanta at multiple times, right? So this is interesting. Interesting. Interessante. So I can also do one thing, unordered map of string bool visited of dep plus comma plus arrival equals false. Okay. Graph visited. I have this filthy looking graph right here. I have the current airport. Then I have this visited map. Now, here what I need to do is if no for string neighbor in graph of current, yeah, I can create get key departure, sorry, not int, string. If visited of from current to neighbor, then continue. Otherwise, we visit that shit. Key equals true, and then I do a DFS on this graph, on this neighbor and this visited, and then I have to push to result as well. So result dot push back current. No, but the point is so the point here is that if I visit, let's say, SFO first, there might not be a possible thing, right? Interesting. So is it like a backtracking thing? Is it backtracking? No, DFS. Eulerian circuit. When have I solved this? I have solved this on April 27. Eulerian circuit. Okay. So we have a graph, we have a out degree, and then we have a result. We create this graph, we create the out degree T0 plus plus, yeah, and then we sort each thing in our graph in interesting. Okay, we sort this, done. DFS JFK, reverse result. While out degree of source is not 0, then we get the iterator graph source dot begin, string destination is this, then we erase that iterator, we erase that from this out degree source minus minus DFS destination. Interesting. How does it guarantee that there will be a thing? I don't know, bro. Return result. Let's see if this shitbox works. I don't know, bro. Result dot pushback current. Pushback result dot pushback. This is string, my friend. This is not an int. For string neighbor in this. What? Basic string. Drops down string graph there. Let's take vector and here for auto p in graph sort p dot second dot begin p dot second dot end. Let's see. Shit. Now this should be this. Yep. Eulerian in departure. This is supposed to be string, my friend. Unordered set of string visited. What? Previous definition visited. Oh, sorry. Another one, let's go. Yo. Visited. What? Oh. Oh no, okay. Dot insert. Sorry. Wow. What the fuck have I done? Yeah, this. Yeah, so this is not needed. Yeah, it works. Please. Come on. But this is way too long. This might be time limit exceeded. Yep. Wrong answer. So this is most likely wrong. Yeah. Yep. Okay. Then my question is, why does this work and why does my solution don't work? I am sorting p dot second p dot wing. Yep. Out degree. Why is this out degree here? What? Eulerian path. Let's take a look. Eulerian path is a path of edges that visits all the edges in a graph exactly once. Eulerian circuit which starts and ends on the same vertex. What conditions are required? Order of E. Reconstruct item LC 332. Why do we need out degree? Okay, we increased out degree. We decreased the out degree of source by 1. Oh, so basically out degree tells us that how many tickets have we used, right? If it is 0, then we can't go anywhere. While out degree of source is when it becomes 0. Let's take a look at some other solutions. We are pushing backwards. The traversal starts from JFK, which is our initial. We initiate a recursive DFS that takes current airport as an argument. Inside this function, we enter a loop that continues until we find an airport that has no more destinations left to visit. This is done by checking the adjacency list for each airport and popping the last element, which is the smallest, in lexical order. Oh. So if I just do okay, sort chat GPT, sort a vector string in reverse order C++. Do I just have to do greater string? Yeah, greater string. So if I just do greater string here, then it works. Is it? No. What? Oh, sorry. This. No. What is the question? What are we preparing for? We are preparing for glory. Interviews, man. Why? What else this website is used for, man? This is LeetCode. Prepping for interviews. That's it. So the point here is to use this algorithm. There is no other way. Let's take a look at this guy. Bro, this guy wrote a fucking... Great. Very, very detailed answer. Okay, so I just need to know this Eulerian path algorithm and we are good to go with this. Okay. You know what? Let's just watch neat code 332. Let me just watch this guy real quick.
Hey everyone, welcome back and let's write some more neat code today. So today let's solve the problem reconstruct itinerary. This is a pretty difficult problem, but it's doable if you have a good understanding of graphs and graph traversals, especially DFS, which we're going to be using in this problem. You know, we want to go over every single edge basically. Each edge result looking something like this. That's one possible solution. But this graph in the first place is, you know, create an adjacency list. Of course, we're already given the list of edges, but and then it also has a second one, sort each of these lists independently. But the easier way to do it is actually just to sort the input, and I'll show you why. Because the way we're going to be sorting the input is by doing this. These are pairs of values, right? The first value is going to be the first key that we're going to pull, and remove ATL from our adjacency list, at least temporarily for now. Our DFS. So let's focus on the picture now. So we're going to be starting at JFK. You know, we have two outgoing edges from JFK. We could go to SFO or we could go to ATL. Which one are we going to decide? Well, we're going to look at our adjacency list and see which one comes first. Well, ATL comes first, so let's visit ATL. So we're going to go along this edge, and now we're going to be at ATL. And when we do that, we're actually going to remove ATL from our adjacency list, at least temporarily for now. And by the way, as we go along this, we're also going to be building our result. Our result is just going to be the travel history of these airports. We know initially we started at JFK, and right now we just visited ATL, so that's going to come next. Okay, now from ATL, we have two outgoing edges. We could go to SFO or we could go to JFK. Which one are we going to decide? Well, let's see which one comes first in sorted order. It's JFK. So let's go to JFK next. So we're going back to JFK, so we visited both of these two edges, and let's remove JFK as a destination from Atlanta. And in our result, now let's add JFK again, because we started at JFK, then we went to Atlanta, then we're back at JFK. Now from JFK, we only have one outgoing edge remaining, SFO, and that you can tell from our adjacency list as well. So let's pop SFO. Now we're at SFO. Let's add that to our result as well. Now from SFO, we only have one destination. It makes things easy for us. That's Atlanta. So let's pop Atlanta from here. Let's go along that edge, and let's add ATL to our result. And from ATL, now we only have a single edge outgoing. It's to SFO. So let's pop SFO, travel along that edge, and add SFO to our result. So this was a valid way because we just visited every single edge. How exactly do we know we visited every single edge, though? Well, our result is going to be keeping track of all of the nodes that we visited in our graph, right? Not the edges. We know every time we visit one of the edges, we're going to be adding another node to our result, and we know we are finished when the length of our results array is equal, so I'll write it out, is equal to the length of our tickets plus 1. So down here you can see when length of results array, and then every other node comes up working, the first path we could go to C first, or we could go to B first. We're going to choose up here the name, or at least sometime a difference just in the that is going to be approximate complexity. We think array complexity is going to be the size of the graph squared, and since we know that the number of edges is actually going to be approximately the city be the create which is tickets. That's what we have to do now. We do is actually iterate through all of the neighbors of our current.
So this is exactly what I did, man. Isn't this what I did already?
Source node, right? So for this source node, and
what is this guy's code, man?
Our adjacency list. Let's not forget. To actually sort our tickets, reversing this decision that we made, and then making a new decision on the next iteration. All the DFS, and we know that the parameter we want should be temp. Okay, now it's
okay. So we are sorting the tickets. Source destination. Adjacency source dot append destination. Result equals JFK. Then we do a DFS. If length of result is equals length of tickets plus 1, then return true. If source is not in adjacency, return false. Then we get the temporary list for IV in enumerate temp. Adjacency source dot pop I, rest dot append V if DFS empty. What? I think he missed something here. Yeah. If DFS of V, adjacency source dot insert IV, result dot pop. Okay. But this feels, I don't know. Yeah, I don't know. What?
This is a pretty challenging problem, but I think that this solution we're going to be passing in. Okay, let's.
If DFS on that V, then return true. Otherwise, it means it returned false. Then adjacent source dot insert IV, result dot pop. Yeah, yep, makes sense. Okay. But this is, I believe, slower. But why does that out degree work in one go, but this doesn't work? Yep. Okay, so let's just do the Eulerian path algorithm and call it a day. So in Eulerian path, what do we need? An ordered map from string to vector of string. This will be a graph. Then we need unordered map from string to int out degree, right, for vector string t and tickets graph of t 0 dot push back 1 out degree t 0 plus plus. Okay, while out degree source is not 0. Okay. So if um should be an if or a while, it should be while out degree of source is non-zero, then I have to get the um string iterator it equals graph of source dot next, right? String destination is star it, correct. Now I have to remove this destination from the graph, so graph source dot remove it, right? And then out degree of source minus minus, then I have to do dfs on destination, result dot push back source. Dot begin, is it? Is it remove or something else? Erase. It is erase. It is erase. Okay. Erase. Uh hmm. 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 Have I not sorted it yet? So if I just sort tickets dot begin tickets dot end, I think this should give me the thing. Yeah. Hmm. Hmm. Why is this slow? If I do this guy, is it still slow? Yeah, this is fast. So what am I doing wrong here? Maybe just this sort. Yeah, might be. No worries. But the time complexity of this is I'm visiting every edge once, so order of E most likely, right? Is it? Right. It'll be order of N. Okay. Yeah, we are sorting, so it'll be E log E. N log N. Yeah, sorting. Yep, makes sense. Cool. This is a good list, man. Good list. Okay, evaluate division. You are given an array of variable pairs equations and an array of real numbers values where equations of I is AI BI. Values of I represent the equation AI division BI equals values of I. Each AI and BI is a string that represent a single variable. You are also given some queries where queries of J, Cj, Dj represents the jth query where you must find the answer for Cj divided by Dj. Return the answer to all queries. If a single answer cannot be determined, return -1. The input is always valid. You may assume that evaluating the queries will not result in division by 0 and that there is no contradiction. The variables that do not occur in the list of equations are undefined. So the answer cannot be determined for them. So for example, we are given this input, equations, values, and queries. So basically, what does this mean is A by B is 2.0, B by C is 3.0. Then queries is A by C. A divided by C. Now, how can I calculate using this? So A divided by B divided by B by C. So it multiplies by C by B, right? So which is not fair? Sorry, what? Okay, so if I create a graph A, B, C, so when A is divided by B, the answer is 2.0. When B is divided by C, the answer is 3.0. If I want to calculate A divided by C, then I have to multiply these two guys through, yeah, A by B multiplied by B by C is equals A by C. So I have to go through this path basically. B by A is simply yeah, I can do a bidirectional thing. This will be 1 by 2, and then C by B will be 1 by 3. If I want to calculate B by A, I can simply just traverse from B to A, B to C. B by C is given already. A by E, I cannot reach E, so it'll be just -1. A is just 1. X is also 1. Okay, so A C, it'll be 6. B A will be 0.5. This is -1 1 1. 6.5 -1 1 1 1 -1. X is not found. Okay, now the point is, in case of irrational things, right? Like 1 by 3 is some outrageous irrational number, right? Not irrational, I mean recurring number. Adit, hello, what's up? Seems all right. Should I do a bidirectional graph? Yeah, maybe. Yeah, makes sense. Makes sense. Makes sense. So, so. How do I store the value? A, B, 2. A to B, B to A. Yeah, I can create a map and I can simply just do the thing, right? I can simply create an undirected graph and I can store these divisions in a separate map. Right? Right? Yeah, makes sense. Okay. Unordered, hopefully, yeah, okay. Unordered map string get key dividend, sorry, it's not, it's string divisor return dividend plus divisor double math. Calculations. Okay, then for every equation in equations, should I also create a graph here? Unordered map of string graph of eq0 dot pushback eq1 graph eq1 dot pushback okay, equations and values have the same thing. Okay, 0 I is less than equations dot size I plus plus vector string eq equals equations of I eq0, right? And then in calculations I have to put calculations of get key when a divided by b, which means eq0 eq1 equals just the result, which is values of I, right? Yeah, and the opposite will be, the opposite is this 1 dot o divided by this. Perfect. Now for each query, for vector string remove all elements from unordered set. Dot clear. Okay, so I can simply create an unordered set called visited, string visited for every q queries. Do a dfs. I have to start dfs from q0, destination is q1, and I have to pass in the graph, right? Yeah. And I have to pass in visited. Let's write this DFS. It'll be just a double DFS. For the graph, I'll just copy this guy. And my source is this. Destination is this. If source is equals destination, return 1.0. Otherwise, what I have to do here, visited dot insert source, then for if visited dot find source is not equals visited dot end, then return okay. Let's take a look at this diagram. If I want to calculate AC, I do a DFS from A. When I am going to B, I need to update my result, which is initially 1. I multiply 1 by 2, it becomes 2. Then from B, I see that A is already visited. I cannot go back there. From B, I go to C. I multiply my result with this guy C. Then I see here that source is equals destination. I simply return 1.0. But if let's say there was a D here, and let's say it was 5, and let's say I see I can't go anywhere. I think I should return 0 here. I could do BFS also. But why do I suck at DFS now? I was a champ at one point of time in DFS. What happened, man? You know what? Let's clear this shit up, okay? Can it be 0? Of course it can be 0, man. Who is stopping? Yeah, values. Oh, values is greater than 0. Okay, interesting. So, okay, then for every neighbor in graph of source, I have to get the result. Answer equals DFS. If I basically go to this neighbor, neighbor destination, and I have to multiply the result here, right? So it'll be calc. You know what? Keep these two guys out here just to prevent overcrowding in this gaff. So I don't need to pass this shit, right? Just source and destination. Calcs of get key. I am going from source to neighbor. Source neighbor multiplied by this. If answer is not 0, then return answer, otherwise return 0. Let's see if this bullshit works. Nope. Visited.find. Visited. Oh, brother. This guy stinks, man. And in DFS, I don't need to pass in graph. Source destination. Graph is not needed, brother. First string neighbor and graph of source. What? Oh shit, man. So this needs to be a vector of string. Okay, wrong answer. What's wrong here? Why is it 1? Source destination. XX. Okay. So, when we are populating this graph, before that, if X is not even present in these equations, what does that mean? If graph dot key set, how to get key set of unordered map? How to check if a key exists in unordered map? I think it's just the find function. Yeah. So before even querying the data, Q0 and Q1, if graph dot find Q0 is equals graph dot end, or graph dot find Q1 is graph dot end, then result dot push back -1 and continue, bitch. Let's see. Okay, works for the sample test cases. Yes. Let's go. Let's take a look at my past solution and see how clean it was. Pretty slow right off the bat. So in DFS, if graph source or find destination is not equals. What? If graph source Graph source destination. What the fuck? What the oh. Okay, so I just did I created a separate map for all of the calculations, but here I just clubbed them into one, which seems a bit more, I don't know, man. It is what it is. I think rest of it is pretty much the same. Source destination, weight is this, insert this. Yeah, 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 pretty much the same. Then in queries, double answer equals DFS source destination. If answer is not is 0, then answer, otherwise -1, visited dot clear. Oh, makes sense. Makes a lot of sense. Then for every neighbor, if visited, if it is not in visited, then we insert that. Oh, we are pre-inserting the neighbor, which is cool. DFS this, if result is non-zero, then return result times this. Yeah, this is, I mean, this is easier for me to understand, but it's the same exact solution. Cool, good question, man. I did this. I'm doing this after 2 years and still in. Number of provinces. This feels like a DFS kind of deal. There are n cities, some of them are connected while some are not. If city A is connected directly with city B and city B is connected directly with city C, then city A is connected indirectly with city C. A province is a group of directly or indirectly connected cities, and no other cities outside of the group. You are given an n by n matrix is connected where is connected ij is 1 if the ith city and jth city are directly connected and is connected. What? Otherwise, return the total number of provinces. Basically, we have to find connected components. That's all. N by n. So the question is simply asking us to do DFS on an adjacency matrix instead of an adjacency list. That's it. So, yeah. I'm pretty sure earlier that I did was just create an adjacency list and just do a DFS and calculate the number of components, which is fair, which is good, which is acceptable. But today we will do this using just adjacency matrix. For this, I need a visited 2D vector of size n. Visited of size n. Now, we simply need to do a two nested loops and check if is connected. I don't think we need to do this, man. I already know that the cities are just n, right? N. ith city and jth city. N by n. I can simply say, why do I need a 2D thing? Yeah, pretty bad. I don't need a 2D thing, brother. For int I equals 0, I is less than n, I plus plus. If not visited, I, DFS of I, is connected and I components plus plus. And for this question's sake, it is provinces. Provinces. Now this DFS function will simply, I can keep this outside and I can do dot resize. Okay. Void DFS. This is my graph, which I'll pass by reference. Int current. Okay. If is visited current, return. Then visited current equals true. For int neighbor in is connected current, if neighbor is 1, sorry, int n or ngh equals 0, ngh is less than shit. Let's pass in n also. We can pass this by reference, right? Just to be clean, just for a cleaner code, that's it. Neighbor plus plus. If is connected current neighbor, then DFS is connected n neighbor, right? And some guy in the solutions would just use this is connected as a visited thing as well, but I'm not one of those guys. I want my solutions to be readable and understandable. Let's see if this works. Yeah, it does. Cool. Next. Cheapest flights within K stops. Modified Dijkstra. He has written the solution in the fucking back brackets, man. Fuck this guy. You know what? I'll just take a break for 5 minutes. I'll be right back. Okay, I'm back. I am back. cheapest flights within K stops. There are n cities connected by some number of flights. There are n cities connected by some number of flights. You are given an array of flights where flights of I equals from I to I price I indicates that there is a flight from to city 2 with cost price I. You are also given 3 integers source, destination and k. Return the cheapest price from source to destination with at most k stops. If there is no such route, return -1. Isn't this just like a fucking BFS or DFS? I don't know, bro. Isn't this just is it Dijkstra? Yeah, it is. So we are given a source and a single destination, right? So it's a Dijkstra. Yeah, it is Dijkstra algorithm. So basic stuff in Dijkstra. What do? We create a distance array, dist of size n. Initially distance is int max, infinity to everything. Then from distance to source is 0 because we are starting at that position. Before that we need to create a graph here, so it'll be just vector of vector int graph. N vector int for vector int f in flights, int source is f of 0, right? Let's call them from and to, and the weight or the price is f of 2. Graph from dot push back to. Okay, instead of this, let's create a pair of int. This pair will store destination and price. So graph from pushback to price. Easy. Now in Dijkstra, we are starting from source. Okay. Now in Dijkstra, we also need a priority queue. What does this do? It keeps the neighbors in a sorted manner, sorted by weight. So basically the neighbor having the least cost to reach to comes first in this priority queue. So priority queue of pairs int vector pair int compare price pq dot push source 0. For compare, I can simply create a struct Yo, bro, yo, what's up? FBI Chinmay. Yeah, I just went for a break, man. Um, yeah. Okay. You know what? I'll just put up a note which says that I am on a break. Mhm. We'll be right back in 15 minutes. Okay, done. I should ideally add a timer here. Yeah. Anyways, okay, I'll be right back in 15 minutes. You know what? Instead of this, I can do some epic stuff like this. I can spin up a Michael Reeves video on stream, maybe. Yeah.
I want to buy a motorcycle. I'm a drug addict, and my drug of choice is lowballing people on Facebook Marketplace. If you've never experienced this narcotic, allow me to paint you a picture. It's 2 a.m. You have work to do, but instead you are lowballing the shit out of some guy named Greg. But do not misunderstand. You aren't here to buy. You are here to gamble on the idea that one of these poor motherfuckers will say yes to your lowball offer one day, instantly catapulting you into the stratosphere of euphoric galaxy feeling. They'll have to shoot you up with Narcan to wake you up. Have I ever successfully lowballed someone? Yeah, I mean, a couple of times. I actually lowballed a guy for this trip. But if I'm being honest, 90% of the time, they ignore me because I'm just not that good at negotiating. But I really, really want a motorcycle for cheap. So, the only logical conclusion, I will use AI to write a bot that communicates with the seller and negotiates for me on Facebook Marketplace. It's what a pussy baby man would say. It's not gonna negotiate. The sole purpose of this bot is to fuck with people on Facebook Marketplace. To lowball them non-stop. To break them down psychologically. Negotiating is for terrorists. And these people are worse than terrorists. Then, when they're at their lowest, I'll swoop in with an offer and give a massive discount. And they'll have no fucking idea.
Oh, shut the fuck up, bro!
Okay, gamers, this code is the first step. I know it doesn't look like much, and that's because I hid most of it because it's very ugly. But it's important because it gathers information for us. And how are you gonna gaslight someone without information? Say you're on Facebook Marketplace and you see something you like. All you have to do is copy paste the URL and then automatically it will open the product page in a Chrome window. It'll strip away all the useful information, the miles on it, the transmission, whatever the stupid ass seller wrote in the description so we can use it later. And by use it later, I mean put it in a ChatGPT and ask it to write a mean message. But man, would it be annoying if you had to copy and paste all of that. Instead, do this. Now we can run this, and no hands, no hand, remind you. Yes, read all that shit. Bring it to ChatGPT. What? Fuck, what is this? Hey, I came across your listing. Thanks? You said thanks? You're supposed to be an asshole. Look, it says right here. Maybe you thought I was just calling it an asshole. Let's try it again. I tweaked the prompt a little bit, and also named the bot Chet. Japiti. Come on, Chet. Let's fucking go, Chet.
I see your post about the motorcycle, and I'm not interested in your sob story. You're sitting on a bike with a salvage title. Do you know what salvage title means? It means junk in bold letters. Who cares about fancy turn signals? I'll take it off your hands for $1,000. Take it or leave it. I've got better things to do than to haggle over your curbside treasure.
That's what I'm talking about. That worked pretty good, and it's pretty much ready to start messaging people for real. But how are we gonna know if it's actually better than a person at negotiating? For that, you would need a control group of people. That would take just too long. That's why I started 2 months ago. Subject 1, Lauren bought this camera listed for $550 for only $450. Good job, Lauren. How'd she manage that?
Hi, would you do 400 cash?
450.
Sounds good.
Powerful stuff. Benoit got this office chair listed for $350 for only $350. What the fuck happened there? Jason got this exercise bike for 10% off. There's a whole bunch more. But in the end, the average amount people negotiated down was 11.6%. That's the number that our bot needs to be. You might be wondering, how is this study in any way scientific? Now we can finally buy something to test out the gaslighting. We could get a blue door, or maybe a Paw Patrol scooter, or I was thinking a new monitor for my computer. Oh no, how'd that happen? Is to fuck with people. Oh man, oh beans. I don't want to talk about it. Anyways, this looks like a good monitor, and for convenience, I made this custom Chrome extension. So you just have to find the product you want, come up here, hit gaslight. A dashboard pops up for the product you want to buy, and you just wait. And wait, and wait, and then this pops up. It's like the Facebook page of the person I am. You don't touch anything, don't touch anything. Boom, okay. Haven't touched anything. It pops up, does it automatically, goes here, bada bing, look at that, fucking puts the ChatGPT message. Yeah!
Hey there, I'm interested in that flickering mess you call a monitor. How about I take it off your hands for 20 bucks? With all that color popping and shit, stop pretending it's worth 50.
Now we just wait. Give him a few hours to think about his life choices, and then I'll make an offer for... Dude, no fucking way. Wait, what? You know how doing like the bot gaslighting thing? The bot sent the message like, fuck you, stupid monitor, and it offered less than 50% of what he offered. He agreed to the bot.
Let's fucking go.
No, that's not what's supposed to happen, dude. What do you mean? No, it's not supposed to. I hope he's not too mad.
Dude, he's gonna beat your ass.
The seller was late to our meeting, which gave me time to think about my strategy. I'm gonna poop my pants. I shouldn't have drank coffee. I'm gonna poop. I was corn dogging. Bad. But it didn't faze me. I had to lock in. Hey, how you going?
Sorry.
No, it's all good.
So I
Nice
spoke
meet
to
you.
your mom or something?
Yeah. I lied.
So she told you about it. I use this for
Like for gaming?
just one gaming.
Just one gaming?
Yeah. Is this good?
I mean, it seems all right. Yeah, I was wondering why you accepted such an aggressive message from my mom.
Oh no, I didn't feel that way.
What do you mean it didn't feel that way? I'm interested in that flickering mess that you call a monitor? You didn't, what do you mean you didn't? Yeah, you said like 20 bucks?
Yep.
Thank you, man, I appreciate it. I had secured the monitor, but I couldn't get rid of a nagging feeling. Dude, I feel kind of bad
Why?
that I didn't get it for less money. Whoa!
Nice feet, bro.
Dude, the bot works first try. Nothing I make ever works first try. Why would you say that? Why would you say that? Oh, hey guys, didn't see you there. Come on. Let me catch you up on what's been happening. It all started right here when I sat down to buy the second thing from Facebook. Oh, your account has been banned. Go fuck yourself, idiot. But it was all right. I thought this was gonna happen. I have multiple accounts. Let's try the next account, and the next account, and the next account. Every single one has been banned. So I contacted my cousin in Pakistan. He gave me the link to a site where I can just buy Facebook accounts. Then I had 50 Pakistani Facebook accounts, and they weren't getting banned. But then they couldn't message anyone. They get prompted for phone number verification because Facebook doesn't trust them. So I do the next logical thing. We're going to Best Buy. Prepaid SIM cards, baby. Oops, you're about 20 years too late. Prepaid SIM card companies recycle phone numbers, so every single one has already been used to make a Facebook account. I've become desperate. I need better quality accounts. So I go on gray market account forums, and finally, I find legitimate looking accounts. And you know what happens? They still get banned! Why? Why? I start to think, why? I got good accounts, I got my software written, I'm using a VPN. Oh! Maybe it's the VPN. So I start researching. Normally when they log into Facebook, everyone has a different IP address. But people using a VPN all look like they're coming from the same IP address.
I am massively simplifying.
So 100,000 requests from the same place make it pretty obvious that that IP address is a VPN. Companies will keep a big list of these addresses. They're called known proxy lists. So Facebook trusts these accounts less. Well then how did I get around this? If you guessed I went back to the store to buy more SIM cards so I can use them like little Wi-Fi hotspots, then you are probably a scammer. But you're right. And it kind of works now. I had to do a couple more things to get it fully functional, but if I say those things, YouTube will get mad at me, so I'll put them on Patreon instead. Good plug. Classy plug. Give me your money. With the bot done, there's only really one responsible thing left to do, and that's to gaslight some elderly people on Facebook Marketplace. No time, no time. Ignore it. Ignore it.
Ignore it.
Ignore it.
I'll be buying it.
Don't worry about it, okay?
$5, huh? Don't make me laugh.
Hello. Hey, how you going? Nice
Good,
to meet
nice
you.
to meet
How
you.
Oh, yep, that's my waifu. Looks beautiful.
Yeah, it's giant. I've never seen
Yeah,
something like
it's
that.
big. You said $3? Do you have any trouble selling it?
A lot of people have asked, not a lot of people buying.
How it going, man?
Yeah, take
How it
it.
going? I got it! I got it! I want a motorcycle helmet.
Listen up, champ. That's a lot to ask for a helmet with scuff marks.
You get a lot of people asking about it?
When I first posted it, not so much, but then the last 3 days I've been getting bombarded with messages.
Welder, to weld things. You know, what do you weld?
I started doing steel sculptures, and now I just I make pillows out of exotic animals,
Okay.
like zebra and giraffe.
It looks like it's got everything. Do you have any trouble selling it?
Yeah, like the female bots that lowball you.
Yeah, bots. Why would I send just one, or two, or three? Everyone I message gets at least 5 bots, all lowballing them all at the same time. Actually, it's over the course of 24 hours to make it not arise suspicion. Let me read you some of my favorite messages that the bots have sent so far. Hey there, nya. I should mention that I've given each bot a different personality by just tweaking the ChatGPT prompt. Hey there.
Yeah, I'm super interested in your Lincoln Electric MIG welder. Since I'm saving up for an epic trip to Japan, I was wondering if you'd accept $65 for it. Arigato.
What the fuck? I sent that shit to a real person. Hey there, I saw
You're listing for the ratcheting wrenches, but my college textbook fees have been really breaking the bank and my spirit. Would you maybe consider selling them for $15?
Alright, I'm over it. This stuff is cool, but remember, I want to buy a motorcycle. So let's see which ones we can afford. Oh, none of them. Because I blew the entire budget on Pakistani Facebook accounts. Seriously though, I want something cheap, like a fixer-upper. You know, it's something I can use all these tools I just bought, boom, come full circle, call back previously in the video, boom, YouTube video, good. Also, those accounts were really expensive. So nothing too nice. Like this, it's cool, but this guy is a little too... Honestly, it's pretty sweet, but I don't think there's anything wrong with it. That's kind of cool. It's only $1,000. Oh wait, this is not even a... Well... This is it. I'm sending the final message for the motorcycle. I've gaslighted this person with every bot that I have. And it's time for me to message them. I'm nervous. Yes, 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 yes! God damn, what the fuck? Anyways, I got the motorcycle. Today's the day. Today's the day. Because of my tailgate, one of the cables is broken. Tailgate? We are on our way to finally pick up the motorcycle. Oh wow, she's beautiful. Hello. Oh, it looks great. You said it runs fine.
Well, I haven't ridden it in a long time.
Don't worry, I didn't understand that either. Because most of the audio from this is completely useless, which is fine. It's fine. What ended up happening is I closed the deal, secured the bike, and all that really matters is that the motorcycle looks fucking sick. Oh man. Okay, so it's not legally or technically a motorcycle. But you guys are missing the point. What you should be asking is how much money did the bot save me on this 20-year-old broken down, not running moped? I got this bad boy for 15% off. And if you remember, the average person gets 11.6% off, meaning the bot saved me $34 off the purchase of this $1,000 vehicle. Let's fucking go. Let's fucking go. And yes, I did spend $600 or $700 on Pakistani Facebook accounts to make the bot run. And no, the moped does not run. Yet. So I'm pretty good at computers and electronics type of stuff, but engines have always just been like a little bit witchcraft type shit, so I don't know what's wrong with it immediately. It makes a noise, like the starter motor makes a noise, but the engine just doesn't start. But I only imagine it could be like the oil. There's a lot of metal on metal contact in an engine, and the oil helps to cut down on the friction between the parts. If someone changes their oil often, it means they take good care of the moped. Attenzione, it's Italian, that means it's the original filter. This thing's 15 years old! That's not great, but let's try, nope, it was not the oil. Or it could be the carburetor's bad. Carburetors are like a mythical, scary thing, but they're actually just like a glorified spray bottle. See, gasoline by itself isn't all that powerful, but when you mix it with air by turning it into a mist, that's what happens in your engine. And that's really all this little fucker does. So I'm just gonna watch a YouTube video on how to clean it. Kind of like how I'm watching a YouTube video right now about carburetors so I can teach you guys how carburetors work. Also, the carburetor was not the problem. It could be the spark plug. It does what the name is. It's just a spark and it lights that gas on fire. Sometimes they stop sparking, but this one sparks, so this definitely won't be what fixes it. Oh. Ah! Yeah! Yeah! I'm the fucking best! Sometimes you don't even have to know what fixes something. You know, you just take it apart, put it back together, and then it works again. And sometimes you weld truck nuts to your moped to justify buying a welder. It's just how life is. So, I think we can conclude that the bot was a success. It saved me $34 on this bad boy, and all we had to do was systematically gaslight a bunch of people on Facebook Marketplace. Now, I did end up telling them about the bot. Those were all me. Who are you? Yeah, it was all us, on like separate accounts. 4, 5, maybe, were us.
It's like a bot.
It was like a bot, yeah. And I ended up paying them the full original asking price for what they were selling, because I felt bad, but I just wanted to see if it would work. And it did, and it saved me $34. Thanks for watching. If you enjoyed the video, let it simmer in your brain, in your subconscious for the next couple days. If you didn't, then don't do that. If you like the shirt I've been wearing, my girlfriend made it, and I'm selling it now. And my girlfriend says if I sell enough, I could win a personal pan pizza from Pizza Hut, so please. It's a really nice high-quality Hawaiian shirt. It's like, oh shit, high-quality Hawaiian shirt. It's got a quirky little Spamusa B pattern on it. It's really nice. So if you're interested, you could go here and go to this website if you want to buy it. And yeah, that's it. Thanks for watching. I'll see you guys in 2 seconds for an ad time. Wow, there's something in the oil. It's a NordVPN ad. You know what a VPN is. Let's not do that again. But Nord offers a lot of stuff outside of its VPN service. It's part of the reason I wanted this as a sponsor. Do you remember when I bought all those SIM cards so I could use their IP addresses? After I did that, I found out that Nord has a service called dedicated IP addresses. Guess what that does? They give you a unique IP address that only you use, which means it's not on a known proxy list, which means websites can't detect that you're using a VPN. I tried it with a bot, and it just fucking worked. So I would have not had to buy 100 SIM cards, which I thought was pretty cool. Like the value proposition of a VPN is like it keeps you safe, right? But most sites use SSL these days, so traffic is generally pretty safe. What not a lot of people think about are malicious websites themselves, which is where a feature like NordVPN's Threat Protection Pro comes in. It's got a malware scanner built in, it deletes tracking cookies, but honestly, the most useful feature is that it can prevent phishing scams. Using a big-ass database of known phishing links, it can help prevent you from getting your information phished, which is incredibly important because they get my ass sometimes. I get an email, it says my Amazon package has not been delivered. I think, fucking monkey brain, click the link. Normally, the biggest threat to our online security is ourselves being stupid. And features like Nord Threat Protection help to protect that. So if you're interested, go to nordvpn.com/Reeves to get you 4 months free off a 2-year plan. It's pretty Not for me, I'm fine. But for my friend Tommy, whose wrist decided to explode after he fell off an electric scooter, it was pretty disgusting. It looked like you took the Photoshop drag tool and just went to his hand. And the doctor was telling us, as he was putting Tommy's bones back together, how common it was to get electric scooter injuries in the ER. It's up there with like car crashes and motorcycle accidents. And it makes you think, like, how can we make electric scooters easier to use and safer for people like Tommy? And we probably come to the same conclusion: make a car out of them. Make a car out of electric scooters. Now, when I say build a car out of electric scooters, I mean it metaphorically. But I also mean it literally. I want to make a car out of electric scooters, where instead of these caveman fucking tires, we slot in scooters, and then I weld together a frame in between them to be like the body of a car. This invention takes all the risk out of riding these dangerous, demonic scooters. No longer do you need the requisite skill to stay upright on one, a talent few in our society possess, if any at all. Instead, just sit down, hit the accelerator, and go. No balance required. But Michael, I hear you ask, how are you gonna hit the throttles on each of the bird scooters to make it all go? I am fucking getting to that. If you would wait just a goddamn second, it'll cut to that part of the video where it's that whole explanation happens, and it'll be cut to very fast-paced music, like Subway Surfers. We got Subway Surfers. The way you accelerate on these scooters is by pressing this little throttle tab with your thumb. I don't want to use my fucking thumb because I can't on 4 scooters simultaneously. So here's what I came up with. It's a 3D printed thumb attached to a motor so it can actuate the throttle on the scooter. That's cool, right? Wrong, it sucks ass. Am I gonna sit there diddling wires together like a fucking Cro-Magnon caveman? No. We're gonna make it wireless for a couple of reasons, but mostly because I'm neurotic. So it's gonna be 10 times more complicated for very little benefit. We can turn this old remote into a controller for the thumb thing. And now it's a detonator. But this detonator can talk to an Arduino, so it's all good. Then we'll take some microwave-safe Tupperware and put the electronics in it. That's not making it past TSA. These are all really basic components you can buy online. They come from a beautiful little place in China called... And just like that, we control the throttle wirelessly. Now you might be wondering why the scooter isn't plowing through my bathroom. And that's because it's got a built-in safety feature that makes you kick off and get a little bit of speed before the scooter accelerates, which might then make you think that's gonna be a problem for scooter car. And you'd be right, but that's foreshadowing for later. For now, I need to try to ride this. Not because I need to test it, but because it seems fun. And so I went into shit-covered Los Angeles to try it out with my friends.
We're definitely not going to an airport with this, right?
This doesn't look sussy at all. It's my remote control car, dude.
Get on the scooter. Oh shit.
Go.
It's great to see that work, but if I were you, I'd be thinking, hey, Michael, dumbass, why don't you just wire into the scooter directly and skip the whole motorized thumb thing? Well, there's actually a really good reason. They're not my scooters. They're public rental scooters that you can rent on your phone. So if I were to wire directly into one, that would be destruction of property and make it illegal. But since we're just renting them off the street and strapping a bunch of electronics to them, that makes it less illegal. All right, now we got 4 of these little fuckers, and I'm gonna cut out the 13 hours of soldering between that last clip and this one. I also noticed a problem with this controller. It sends the same signal to each of the little throttle things, so they all do the same shit, but we wanna be able to talk to each one individually. And for that, we're gonna need a more advanced controller. So I got this Wiimote steering wheel off of eBay. Now, I'm not good enough at electronics to make a Wiimote talk directly to these thumb things, but if we slip some software, some coding in between the two, I'm pretty sure I can make it work. Now, some people would call that compensating for my crippling lack of electronics engineering skills using computer programming. And I would also call it that. That's exactly what I'm doing. Hey, kid. You wanna learn some Python? First thing, you're gonna wanna see if you can even fucking communicate with these things, so open up your little code editor and we'll write some code to test it out. This line says connect to an Arduino over USB. That's our little transmitter here. And these guys are just variables. They're numbers. They say how much and which motors to move. These lines down here tell our transmitter to send those variables over to the thumb thing, and if we run it, it should... Nice. Put a cute little function up there. We'll save every scooter address in an array, and now if we loop through that array, and now if we loop... What the fuck, man? Just run the fucking... Bro! I hate you. I hate you. I hate you. I hate you forever. Huh? Yeah, right. So the next thing I should do is kill myself. Connect to the Wiimote steering wheel. We kind of just capture the steering wheel's position and use it to draw this red ball. But it gets a little cooler when you combine it with the code we wrote earlier. Now, depending on which way I turn the steering wheel, the throttle lays off on that side of the car. And with only one side of the car powered, scooter car will turn in that direction. I hope. I don't fucking know. I haven't tested it. Well, you should probably go test it then, huh? Stupid. So it's time to go kidnap some scooters. Initially, I was worried how I would get these back to my house. But then I remembered I own a white truck with a light on top of it, which essentially makes me God on the streets of Los Angeles. And with that sorted, we just need a quick montage to hook these guys up. And, should be good to go. Problem, the front wheel can still turn, which is definitely a fucking problem that we have. We need a system to immobilize the front steering column entirely. So here's what I designed in Fusion 360. And here's what I actually made. I call it 2 clamps from Home Depot I welded together in my garage. Okay, all the controls are running, I got the software running, and I just activated all the scooters on the app. The controls look good. I'm gonna bank a right turn out of the driveway and we'll test it out on the street. A little push. Huh, I'll be honest with you. I meant to crash it into my truck as a goofy, haha kind of meme. Classic comedy. But I also 100% in my heart of hearts believe that when I turn the steering wheel, it would turn. I believe so much. And nothing happened when I turned the steering wheel. So I went in and did a Boeing 737 crash site analysis. I rebuilt the frame out of stronger wood so I could test why it didn't work. And I discovered some very disturbing things. Namely, it was that I didn't understand the concept of like steering in general. You cannot just power one side of a vehicle and expect it to turn. You are now watching a live video of me encountering this concept for the very first time. And like a child who cannot grasp reality, I keep trying to make it work. Cars don't do that, ever. I do not know where I got these ideas. My only hope is that I'm becoming schizophrenic and a voice told them to me in the night. But I can't give up. Tommy's out there somewhere with a broken hand. What if he tries to ride another scooter? He's so bad at riding scooters. I need to do this for people like Tommy, who is, again, so utterly dog shit at riding scooters. We need to pivot, literally pivot the front half of scooter car to change the direction of our rotational velocity. Am I using that word right? Here's a chart, you figure it out. We'll need to ditch the wood and go with a metal frame with a heavy-duty rotating hinge. Like this one? Exactly like that one. It will take days, maybe weeks to weld. Oh no, there it is. Yeah, no, I cut all that shit out. It's boring, but if you wanted to watch it, here. See, everyone's happy, except for me, because I, again, haven't tested it yet. Well, you should probably go fucking test it then. Yeah, no, I know, thank you. It's just, I'm kind of worried. That epilepsy montage was maybe like 80 hours of work. It shouldn't have taken that long. It's because I learned to weld on YouTube, and also this fucking part, it holds the bearings that lets the whole thing rotate. I had to make it on a lathe, which meant I had to learn how to use a lathe, which meant I had to buy a lathe on Facebook Marketplace. And I also bought this couch on Facebook Marketplace. This is not an ad, I just buy a lot of stuff from there. What I'm hoping is we can use the same concept as before, where we use the scooter speed to steer the car. But this time they have a nice pivot to work around, and also it's only 2 scooters turning, so it's like a line instead of a square. So that should work, right? I think I smudged it. Fuck. Just get that out. It's so beautiful. I'm looking for a parking lot big enough to test this in. Last time I tried it in my driveway, I got a couple places in mind, like the roof of a Westfield mall. Just gonna move these. I got kicked out pretty much immediately. New spot, found it, we're trying to figure out how to take a piss. Not how to take a piss, like a place to pee. I'm in the back parking lot of trying to hide from their security. I'm hiding everything behind my truck, but I don't know how long that's gonna last. I think I just have to test it out. This one's not unlocking, and I don't know why. This can't be real. One of them is not unlocking. Why is it just this one? I literally tested it. Please. Oh my God, it fucking worked. That's all for. That's creepy. Oh. Yeah! Yes, it steers. Yes. Oh shit. It actually steers. Let's go again. Yes, yes, yes. Now, right? Yes! Yes! I think the reason we had that little issue was because scooter car got outside of the range of the transmitter, which won't be a problem when I actually ride it because I'll be on it. So that's good. Now we're gonna go right. Okay, and now back left. Oh my God! Do you see this? Oh shit! Oh shit! Yeah. Right. Brakes. Shit, honestly, I'm gonna add more than just brakes. Welcome to the future. Come here, let me show you what we got. Huh, brakes? Yeah, we got brakes. So the scooters actually already have brakes on them. They knew that. Stupid. So I just took a $9 air piston and 3D printed a bunch of bullshit onto it. And now you can control the brake with compressed air. Don't worry, I've already tested it out. It's pretty good. Yeah, I could have spent time with my family, but instead I spent days making brakes for a scooter car. You're wasting your life away, you idiot! You fucking moron! Check this out. We got a custom push-off system. Look at this. You might be wondering why we need a push-off system. Well, you obviously don't fucking listen.
Makes you kick off and get a little bit of speed before the scooter accelerates.
So we'll use a big metal piston to give us a push. Uh-oh, not enough friction. I wish we had something made out of rubber. Take off your shoe. Cut your foot out of a sheet of metal. Breathe a bunch of poison gas. Nice job. Now if you have trouble with friction, just take off your air forces, put the metal plate in, screw it to the piston, and wow, look at all that friction. Wow. Nice job. Hello? That was Elon. Blow up his house. Custom bodywork, a spoiler, top a custom synthetic leather seat. Oh, we need a chair. Come on. So big. Should I like cut the seat? I think about all the dangerous things on this thing, and then I realize I'm in too deep. Like, I can't stop. Shut up, dumbass. No one cares. It's got everything. Only one thing left to do is to make Tommy's wish come true. I mean, not now, like probably tomorrow morning. It's tomorrow morning, and the plan is simple. We drive scooter car across Los Angeles directly to Tommy's house. This won't be easy, but it's just the right thing to do for a poor boy with a broken hand. And that's good enough for me. Can you believe this idiot broke his hand on a scooter? No, I don't give a shit about his arm. It's like charity work, you know? Think of all the attention I'm gonna get for helping his ass. Are you still recording? I'm coming, Tommy. Can you guys help me get it over the lip? Okay. Dude, it fucking works! It like turns and shit. Dude, it fucking turns! It works like for real! Progress is good, but we're approaching the first major obstacle. Big road. 4 lanes of traffic with no stoplight. In scooter car, even the modest Prius will headshot you like child versus minivan. But no matter, I've already lost all regard for human life and safety. She handles it like a fucking champ. She does it like a fucking champ. She can do the turn. How you going? It's hot out, no? Fuck. One of the scooters is giving out. Oh no, it's probably the low battery one I started with, so I could create conflict because this is a YouTube video. But that's no problem with scooter car. Grab a scooter from wherever, and you can simply replace. Let me show you how. Disengage the parking brake. Locate a high lift jack. Jack it up a few inches, unplug, and remove your electronics. Don't lose that. Can't buy another one of those. Unscrew and remove your braking system. Remove the throttle motor servo. Undo the rear clamp. Undo the front clamp. Remove the low battery scooter. Shut the fuck up. Insert the fresh scooter into your scooter slot. Clamp up your scooter. Electronics. The wrong way! Don't forget your throttle. Plug it back in. So you return your brakes so you can stop at stoplights. And just like that, you're ready to rock. This fucking sucks. Could I get a 1 number 4, the meal? From here on out, it's smooth sailing. Except for the street, which is blind in both directions with 0 visibility. Wait, it's fucking remote control. I can just stand up. Forgot his remote control. You just do whatever's, you know? And after a long journey, we were finally about to reach... Tommy! What? I got your car.
You have my what?
Where's your fucking cast? Where's your
It's
cast?
gone now. It's been months.
The whole video hinges on your arm being broken. The video doesn't make sense now. You understand? You understand how the video doesn't make sense now? Do you get it? Come on, let's get a cast. Let's get a cast.
Okay. What is
Come on,
this?
it's your car, bro. So you don't fall on a scooter and break your hand ever again.
This thing looks more
Shut the fuck
dangerous.
up. None of this makes sense without a cast. So you sit inside of it. You sit inside. Yeah. You're not driving.
I don't
know.
have...
See you later, dumbass. Just sit on my lap. Okay. Don't worry, baby. Feel a little speed. Feel that you get a little speed. Oh, wow. Acceleration go crazy. I can't see too good, so if you could point out, like, what's going on.
So how come you have a helmet, but I don't?
This is fucking dangerous.
I think it's just a right now.
Oh,
This
shit.
is Santa Monica. Holy shit.
I know. This was not part of the plan.
Oh boy.
Ignore it. Ignore that. Ignore it.
There's shit dangling.
Ignore it.
out front.
Ignore it. Okay, fucking get off. Get off. This arm? Oh.
Ow! What the fuck, man?
Bro, your arm has to be broken to put it in here, which kind of does make sense when you think about it. It makes sense. The video makes sense. Get you in your car. It feels better, huh?
Yeah.
Hey, man, you're welcome, and there's no need to thank me, actually, for real. You enjoy this, okay? Have fun, all right?
I'll enjoy this.
Fucking dumbass. Thanks for watching the video. If you liked it, share it in your family group chat and favorite Discord Dooning server. 5 a.m. I don't even know where I am anymore. If you want to see Scooter Car in person, I'm actually taking it to Open Sauce. It's a convention that my ex-roommate puts on every year. It's like an adult science fair. It's not porn. I feel like every time you say adult, you have to preface that with it's not porn. It's essentially hundreds of booths that the biggest nerds on planet Earth showcase their stuff in. I think my favorite from last year was a shrimp that fried rice. But yeah, it's cool. It's in San Francisco and it's going on June 14th to 16th. And if you go to see Scooter Car, you can sit in it and you can mess with the buttons. I haven't asked Will about this, but because I'm saying it, he'll be forced to let you do that. Yeah, maybe I'll see you there. And what else? Oh, sorry the video took so long. I promise the next one will be faster, more lies, and oh, Tommy didn't really break his hand on an electric scooter. He broke it on an electric toy moped that I built, and he broke it because it didn't have any brakes on it. And that's why we're in the emergency room together. And that's it. Yeah, okay, thank you. And that's a perfect time to talk about today's sponsor, Odoo. Why go to many places for website building when you can get it with Odoo? Odoo didn't like that version for some reason. Let's do another one. Odoo's trying to be like a one-stop shop for all the annoying parts of managing your business. They have an app for accounting. They have an app for e-commerce. They have an app for website building. Could you imagine how boring it would be to make all of those things yourself? I mean, the website's kind of cool. Say I wanted to make like an open source blog about like turning scooters into a car. You start with a few prompts about what you want to build. Then you choose a color palette, pick out what you need the site to do and what pages go in there. And you get to choose between like 3 different versions of the site. They say they use AI to generate the site. I'm assuming that means choosing the stock photos and page layout that best fits your business.
Okay, I'm back. Okay, let's get this going, man. Okay, so I was on cheapest flights within K-stop, so I need the extras here. I'm pushing the source, and then while PQ is not empty, what do I need to do here is get the current one. Then for every neighbor, in graph of current, if distance of neighbor is if distance of neighbor is greater than new cost, then distance of neighbor equals new cost, and PQ dot push neighbor new cost, right? Where are you from? FBI Chinmay. I am from India, brother. Okay, PQ dot push this and this. Bool operator, this const pair int a const pair int b return a of shit a dot second should be less than b dot second. And I messed up here. This should be current dot second. Got exams, will see you tomorrow. Great. All right, good luck for exams, brother. Graph current. What? Wow, 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 wow. What? Graph current. Oh, current dot first, brother. Shit. Neighbor dot first dot first. Shit dot first. Bro, I'm so bad. I am so bad. I am so bad. It should be DST, my friend, not dest. Okay, 2 failed. Oh, K, I didn't consider K at this point. Okay, so I have created a graph. I have created a PQ. I am pushing source. With at most K stops. So instead of a pair, I also need to store how many stops I've taken already. So I can use a struct here. Struct, let's call it city. This guy has an ID. It has a cost associated with it. Stops taken. And ID. Let's just call this stops. You know what? Fuck this. I've already done here. Cost source is 0. Oh, I don't need to create a graph, man. I'm creating a temporary copy of cost. Then I'm going through each flight from to and price. If cost from is not int max and cost from plus price is less than or equals temp 2, then we are updating the price. Cost equals temp, and we are doing this just k times. So this is Floyd Warshall, right? This is not Dijkstra's. I don't know, bro. Is this Floyd Warshall Solutions? Bellman Ford. Is this Bellman Ford? I think Floyd Warshall is way too rogue here. Let's see the extras. Yeah, run the algorithm k times. In Dijkstra's, we have a map. We are creating a graph, a priority queue, just two things. Q dot add new int. Yeah, three things: cost, The next neighbor. Next 0. What is next 0? I think, yeah, the next thing. And stop -1. Okay. Yeah, yeah. Same shit that I was trying to do here. Neighbor stops +1. Do 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 do. A cost, B cost. Wow. Why is this? Okay, so something wrong here. Okay, brother. Okay, K is 1. So 1 is allowed, right? Oh. K is 1 here still. You know what? Reset this shit. And we simply need a Bellman Ford here. Let's take a look at Bellman Ford. What's the problem? What's the thing? Bellman Ford is single source shortest path algorithm that can detect negative cycles. Time complexity is E times V. When to use when the graph has negative cycles, because Dijkstra's cannot handle negative edge weights. Okay. Set the distance to starting node as 0. Relax each edge V minus 1 times. Okay. Dist n int max. Then for int I equals 0, I is less than equals k I plus plus. Distance of source is 0. Now for vector int f in flights, from equals f0 to equals f of 1, cost equals f of 2. If distance of from if distance dot from is not equals int max and cost plus distance of from is less than distance of 2, then distance of 2 equals cost plus distance of from. Return distance of destination. What? I think we just need this. What? Still 400. Oh, I have to update. Oh, sorry. Okay. Okay. If the original distance is not int max and cost plus distance from is less than temp2, we update the final distance in temp. That is tricky, man. Fuck. What? Okay, Bellman Ford is weak. I need to revise these guys again, man. Fuck this shit. Okay, this was Bellman Ford. LC743787. Yeah, let's do 743. Network delay time. Okay. You are given a network of n nodes labeled from 1 to n. You are also given times. A list of travel times has directed edges. We will send a signal from a given node k. Return the minimum time it takes for all n nodes to receive the signal. If it is impossible for all n nodes to receive the signal, return -1. Okay. Bellman Ford. We need vector of int distance, size n. Initially everything is int max. We initialize the signal from, we trigger a signal from node k. So distance of k labeled from 1 to n, so it'll be n plus 1, right? Distance of k is 0. Distance of 0 is also 0. N nodes, right? Currently only one node has received the signal, right? Then while true, apply Bellman Ford here. So we copy this distance into a temporary array. Then we go through the times, t in times, right? Then we check int from equals t0, to equals t1, and cost equals t2. Now then we check if distance from is not int max, and it means that signal has reached the from node, and cost distance of from plus cost. Okay, now the key point to note here is there is no cost involved actually. It is time it takes. Oh. What? Why is it time limit exceeded? Okay, why is it time limit exceeded, brother? 2 1 1 2 3 1 3 4 1. K is 2. We start from 2. Distance of 2 is 0. Right. Oh, while true. Yeah. Okay. So I have to run this loop n number of times. Int I equals 0, I is less than n, I plus plus. Yeah, Bellman Ford works fine. I can write Dijkstra's for this as well, since the weight is positive. There is no negative weight here, so we can write Dijkstra's as well. Let's quickly write Dijkstra's, man. For Dijkstra's, we need the same thing. Distance of 0 is this. This is this. But before that, we just need a graph here. Int graph of size n. Instead of this, we can simply do a pair of int. while PQ is not empty, then we get the current PQ dot front, or I should call it PQ dot top, PQ dot pop, right? New cost equals sorry. Then for neighbor in graph of current dot first, right, int new cost equals what do we call this, current dot second plus neighbor dot second, right? Yes. If distance of neighbor dot first is greater than this new cost, then distance of neighbor dot first equals new cost PQ dot push neighbor and new cost. Boom, boom, boom. At the end we get here return distance of DST is int max question mark -1, otherwise distance of DST. Oh, sorry. I still have to return the max element. My bad. Oh, neighbor dot first, man. Heap buffer overflow. What? Current first. Graph vector PD current first. What's wrong here? Why is this heap buffer overflow? PD current equals this current dot first. Okay, if new distance is this, then pq dot push this. Why is this heap buffer overflow? What the fuck is wrong? Current dot first. Oh, basically, okay. Oh, sorry. This needs to be n plus 1, brother. Brother. Yeah. That's why. So this is Dijkstra's, simple Dijkstra's. Yeah, it is somewhat faster. Easy, no worries. Okay, done. All paths from source to target. Given a directed acyclic graph, acyclic. Is it acyclic or acyclic? I think it is acyclic. Acyclic pronunciation. Acyclic. Given a directed acyclic graph of n nodes labeled from 0 to n minus 1, find all possible paths from node 0 to node n minus 1 and return them in any order. The graph is given as follows. Graph I is a list of all nodes you can visit from node I. Oh, adjacency list is already given. So if I start from 0, right, 0 to n minus 1. Zero. Return result. If source is n minus 1, then current dot push back source, result dot push back current dot pop back in return. For every neighbor, I need to push this neighbor to my sequence and then call DFS on this neighbor and then pop back that neighbor. Since the source will always be there, current dot push back 0 visited dot resize and false. Oh, what? Graph n neighbor. Zero 4 0 3 4 0 1 0 1 4 is nowhere to be seen, brother. Shit. Oh man, fuck. Yes. Yep. Oh, first time. Yeah, pretty easy. Directed a cyclic graph. Find eventual safe states. Okay, what's the time? It's 11:30. So what I'll do is I'll just solve these two questions and then I'll take a 5-minute break. Then I'll get on with the DP questions and that's it. I'll just sleep and then okay, fuck it. There is a directed graph of n nodes with each node labeled from 0 to n minus 1. The graph is represented by zero-indexed 2D integer array graph, where graph of I is an integer array of nodes adjacent to node I. The graph is represented by a zero-indexed 2D integer array graph, where graph of I is an integer array of nodes adjacent to node I, meaning that there is an edge from node I to each node in graph of I. A node is a terminal node if there are no outgoing edges. A node is a safe node if every possible path starting from that node leads to a terminal node or another safe node. Return an array containing all the safe nodes of the graph. The answer should be sorted in ascending order. If every possible path starting from that node leads to a terminal node or another safe node. Okay. Return an array of containing all safe nodes. What is a safe node? Where all of the paths starting from that node end up at a terminal node. Terminal node is a node where there is the outgoing degree is 0, right? 5 and 6 are terminal nodes. Every path starting at node 2, 4, 5, 6 all lead to either node 5 or 6. Right? Yeah. I did this yesterday, right? Dependency graph basically. In degree P0 prerequisites. For example, the pair 0 1 indicates that to take course 0 you have to first take course 1. 0 to 1. So 1 has a dependency on 0. So in degree of 1 is 1, in degree of 0 is 0. Right. Right. Then Q. Okay. Yeah, similar, we need to do stuff here. So we calculate in degree and then what can we do here? If I just calculate in degree of terminal node where there is no outgoing stuff. Okay, this is confusing. So, should I calculate in degree or out degree? I mean, I already know the graph here. By in degree, it means like dependencies and stuff like that. But this is a different deal. Topological sort. Topological sort is like a dependency graph. Like first you need this and then you need that, stuff like that. If I flip these arrows, then maybe I can get behind this, right? Yeah. So if I flip these arrows, this goes here. So then in degree of this will be 0. This has always been 0. In degree of this will be 1. Yeah, stuff like that. Maybe I'll just look at... Oh, I've solved this already. Oh, in Java? Fuck off, man. Is this Java? Shit. Create inverted graph, correct. Inverted graph create, then we get the out degree. Oh, we are calculating the out degree now. For int I equals 0, I is less than n, out degree of I equals graph of I dot size out degree. We are calculating out degree here on the original graph, not the inverted thing. Out degree on the original graph. Okay, then what are we doing? Find the nodes with 0 out degree. In Q, we push the nodes where out degree is 0. This means that these are terminal nodes. Then in the result, topological sort. While Q is not empty, current equals Q dot front, result dot pushback current. Decrease out degree of nodes connected to current. Now, okay, out degree was calculated on these guys. So out degree of this is 0, this is 0. Out degree of this is 1. Out degree of this is 1. Out degree of 2 is 1. Out degree of 1 is 1 and 2. Out degree of 0, 1, 1, 2, 2. Now we know we have the inverted graph, right? So 0, 1, 2, 3, 4, 5, 6. Inverted graph will look something like from 5 it goes to 4, from 5 it goes to 2, from 3 it goes to 1, from 2 it goes to 1 again. Bro, my brain is lagging. Yeah. Now we have what's the problem here? In the inverted graph, we get the current. Now here 6 is pushed. 6 has nothing. 6 has no neighbors in inverted graph. So this will just be nothing. Then we push to result, which we're already pushing. Then we get what do we get? We get 5. Out degree of 5 or 0. Then we are decreasing out degree of 4 and 2 by 1. So 4 becomes 0 and 2 becomes 0. If these become 0, we push it to the fucking Q. Right. And then we pick 4. From 4, nothing is going out, so it just collapses. From 2, 1 is this is going and this is going, right? So we decrease 1 and 1. So it's just 2, 4, 5 and 6, isn't it? Is the answer for first is 2, 4, 5 and 6? Yeah. Makes a lot of sense. So the point is to calculate out degree and invert the graph and then do a topological sort the result, and that's it. What a fucking... Okay, let's do this. Calculate out degree and make on original graph. Create a separate inverted graph. So graph dot size vector of int out degree n 0 vector of int inverted n vector of int for calculate topological sort sequence. So while Q is not empty, we get the current guy, which is Q dot front, Q dot pop, result dot push back current, decrease out degree of current. Neighbors of current in from inverted graph. For int neighbors of env current out degree of neighbor minus minus, if out degree of neighbor becomes 0, then q dot push neighbor. Cool. Key and rooms. There are n rooms labeled from 0 to n minus 1, and all the rooms are logged except for room 0. Your goal is to visit all the rooms. However, you cannot enter a logged room without having its key. When you visit a room, you may find a set of distinct keys in it. Each key has a number on it, denoting which room it unlocks, and you can take all of them with you to unlock the other rooms. Given an array rooms where rooms of I is the set of keys that you can obtain if you visited room I, return true if you can visit all the rooms or false otherwise. Okay, all of the rooms are logged except for room 0. Isn't this just a fucking DFS? You know what? Fuck this. Visited of 0 is equals true. Then we simply check the key in rooms of source. If not if visited key, then continue. Otherwise, visited key equals true. DFS key rooms. Okay, easy. Okay. So one thing to notice here is, okay, I have covered topological, I have covered Dijkstra's, I have covered Bellman-Ford. I haven't covered Floyd-Warshall, so let's take a look at that also. And bridges and articulation points, I'm not covering this time also. Fuck this question, man. Floyd-Warshall. This is an all pairs shortest path algorithm. It finds the shortest distance between all pairs of nodes. Time complexity is V cube. Ideal for graphs no larger than a couple of hundred nodes. It can detect negative cycles. So the memo table, it'll be a 3D matrix Kij, which stores shortest path from Ij. Which stores shortest path from I to J. Routing through 0 to k nodes. Specifically, dpn minus 1 is the 2D matrix solution we are looking for. When k is 0, routing through 0 to k nodes, 0 to k nodes. Adjacency of ij, otherwise dp of kij equals minimum of dpk minus 1 ij, dpk minus 1 ik plus dpk minus 1 kj. What the fuck is this? We can convert memo table to 2D by changing the values in place rather than storing the state k minus 1. So it reduces to when k is 0, dpij equals adjacency of ij. Otherwise, dpij equals minimum of dpij, dpik plus dpkj. What the fucking load of shit is this? LeetCode 1334. Copy, paste. Find the city with the smallest number of neighbors at a threshold distance. There are n cities numbered from 0 to n minus 1 given the edges where edges of this is from I to I. Weight of I represents a bidirectional and weighted edge between cities from I and 2i. And given the integer distance threshold, return the city with the smallest number of cities that are reachable through some path and whose distance at most is distance threshold. If there are multiple cities, return the city with the greatest number. So how do we apply Floyd-Warshall here? Yeah, makes sense for every edge. Source, destination, weight. Yeah, makes sense. K and I, J. This is just... I hate this Floyd-Warshall, man. You know what? I'll just take a break, man. I'll be right back in like 10 minutes. Okay, I need to watch a Floyd Warshall tutorial, so I'll just hop on to leetcode. And the problem is 1334.
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve the problem, find the city with the smallest number of neighbors at a threshold distance. And sometimes, to be honest, I wonder, why do people even watch my videos? And then I go and look at the editorial and I see this behemoth of a solution. I don't know why they needed 84 lines to implement this. I mean, they do have some comments here and there, but still, 84 lines. You can see my solution is going to be less than 30, and I think it's still pretty readable, so you can be the ultimate judge. But let's get into this problem, which I think I actually solved 4 years ago. The idea is we're given a graph. I don't necessarily know if it's a connected graph or not, but in any case, it is a weighted graph. Each edge has a weight, and each edge is undirected, so it goes both ways. And the idea behind this problem is that, consider for every single node, we want to know from here how many nodes could we reach without traveling a distance greater than 4. The max distance we can travel is 4. That's the max total distance. So you can see that one path we can take is this direction, that's 3. And then from here, we can go down to this guy. That's a distance of 1, so the total distance of this would be 4. At that point, we can't really go further unless maybe if this was a 0, but I don't think we have to worry about negative edges or anything like that, which is going to make our life easier. But we can't really go any further from there, so maybe from here we can go, but no, with a distance of 3 plus 4, this one is not going to work. This one is not reachable. So from this node, we can reach 2 other nodes. And you can kind of follow a similar process, so let's just record that. For 0, it's 1, or sorry, it's 2 nodes we can reach. And then from this guy, we can go here, we can go here, and we can go here as well. So actually from here, we can reach 3 nodes. So we'll say from 1, we can reach 3 nodes. And we can continue from here, we can go 1, 2, and 3. So actually 2 can also reach 3 nodes. And finally, 3 can go 1, 2, it can never reach this guy, because that guy could never reach us either. So 3 will have a count of 2. Now, among all of these, we care about the ones that can reach the minimum number of nodes. These ones can reach 3, but these 2 can reach only 2 other nodes. Now, since there is a tie, how do we do a tiebreaker? Well, we choose the node that has a greater value. So among these 2, we would favor this one, and so this would be the result. That's the return value in this case, as you can see down here. So let's consider the brute force, because we can't really do much better than the brute force in this problem. And even the brute force might be hard enough for you. I think for a medium problem, this is not going to be trivial. So let's just kind of focus on that. There are multiple ways to solve this problem. Let's just first start with DFS or BFS. Which one of these 2 algorithms do you think is going to be better in this case? Given a node, we want to know how many other nodes we can reach. We can travel in any potential direction. Generally speaking, BFS is better for that. Now, under the family of BFS algorithms, there is a very popular algorithm. You might have heard of it, and it might make you nervous just thinking about it. Dijkstra's algorithm. I cover it heavily, I think, in my advanced algorithms course. You can even implement it from scratch, I think, in one of the code sandboxes, which is free on leetcode.io. Why exactly will that be helpful here? Because we have a threshold. Well, why is that important? Why is that a BFS thing? Why is that related to Dijkstra's? Well, consider this. From here, we're asking what are all the other nodes that we can reach, and we want to stay under this threshold. So, if there is a path from 0 to 1, of course, we would want to find the shortest path there, because taking the long path to get there is useless, because then we might exceed the distance threshold and not recognize that we could indeed reach the other node from 0. That's the intuition behind this. Now, even if you recognize this, how are you going to solve the problem? Even if you don't know maybe how to even implement Dijkstra's algorithm, you still, at the very least, could probably give me the high-level solution, which is from every single node, we're going to run a Dijkstra's algorithm, like an augmented version of it, slightly modified, and we're going to determine which are the nodes that we can reach. First of all, which nodes can we reach? And once we have those, we can obviously count those nodes and then return that. So running a Dijkstra's algorithm from every single node as the source node will give us what are all the nodes that we can reach. Suppose we're given n nodes. What is the time complexity of Dijkstra's algorithm? Because that's going to be the overall time complexity. Well, well, this might make more sense in the code, but if you remember how Dijkstra's is implemented, we do use something called a heap. Specifically, we're going to use a minimum heap because it is a greedy algorithm. And the max possible size of that heap, you might first think it's going to be n, where n is the number of vertices, but let's say it's actually e. But e is never going to be greater than or equal to n squared, right? I think that roughly makes sense because for every edge, it can only be connected to every other node, right? So this is pretty fundamental. So if you believe this, you know that the max size of the heap is going to be e or n squared. So let's say n squared for a second. So pushing and popping from that heap of size n squared is going to be log n squared operation. If you remember how logs work, this too actually becomes a constant. So that's why we don't care if it's n squared or if it's n, because it will pretty much reduce to log n. So that's going to be the time complexity of pushing and popping from the heap. Now to run a Dijkstra's algorithm, every node could be added to the heap not just once, but actually n squared times, because again, that's the number of edges that we have in the graph. So like if we had like 5 edges connecting to this node, that node might be added to the heap that many times. So this is the time complexity of Dijkstra's algorithm a single time. So if I just insert that over here, you can do the math and pretty much get that the time complexity is going to be n cubed log n. I don't think it makes a ton of sense to go further into this explanation. I think I probably have a much better video explaining exactly how Dijkstra's algorithm works, and I'm pretty sure it's free as well. So if you just go to leetcode.io, and I think under the basics tab, if you search for Dijkstra's, there should be a very detailed explanation exactly for how that algorithm works. I think you should start there because I'm going to run a slightly modified version of that algorithm right now. Before I implement the code, I wanted to quickly mention that right before I started recording this video, I was actually working on adding these animations to the DSA for Beginners course. You can see, I think, that these are going to be very, very helpful for visualizing exactly how an algorithm works. So I have this right now for Matrix BFS. I also have some animations for how like an adjacency list traversal works. Pretty soon, I plan on adding animations for the advanced course as well. Don't quite have one for important, so I'm actually going to add a tuple here. If you wanted, you could add at least implement the part that you know how to do. We know, at the very least, we want to run Dijkstra's on every single source node, and that it returns the count. Then we want to minimize that count, so I'm going to declare a couple variables up here. First, I'm going to have a result. That's going to be the resulting node n, because everything we just computed. Now, try to guess why I did less than or equal. Consider the case where there's a tie. We're going through these nodes in order, in a still favored algorithm. And I think that's only going to be to the heap. So here we stay under this threshold. If that's, we're going to say that's exactly what we added to the heap. So once you have that, if this node has already been visited, it doesn't make sense to go through all the neighbors of that node and then push them to the heap again, because again, Dijkstra's is a greedy algorithm. Like the first time we reach a node, I'm going to call this distance 2 because I'm not very creative, but you might have a better variable name for it. Now, we want to know the total distance. We're going to assume that this distance given to us is the total distance to reach this node. Heap push to the heap, a tuple, which is the neighbor distance, and second, the neighbor node itself. You might be tempted to do this, but don't forget, we do have to stay under that threshold, so you try to guess what I'm going to do here right now. It's not super complicated. We're only going to check if the neighbor distance is less than or equal to that distance threshold, then we are going to do this. Otherwise, if we went over the threshold, just feel free to skip that neighbor. So not bad. It looks like we got it done in about 28 of them. And then down here, we're literally just running it a bunch of times on every source node, keeping track of which one had the minimum count, and then returning it. And you can see that this solution is pretty efficient. So I'm going to go ahead and leave things there and probably go get back to work. Hope you have a good day.
Okay. Cool. Okay. So yeah, Floyd Warshall is a spin on Dijkstra's basically. I mean, yeah. So, all right. Bro, you know what? I'll just sleep, man. DP, I'll just do it. I'll just see some questions in the morning, and that's it. Because I feel like I need to rest. But my brain is deeply fried. So yep, I'll be back tomorrow after my test. So yeah, I'll see you guys tomorrow. Goodbye.